Okay, everyone, this is Mr. Kier. In this video, we're going to be continuing our free body diagram experience, but this time we're going to be including numbers. So this page in your workbook, I'd like you to modify it a little bit. The way I want you to modify this is I'd like you to use the following. So we're going to have north being positive. So whenever you have northern force, can you put a positive sign there? And a southern force, you're going to put a negative sign there. And similarly, anything that's going to the east will be positive, and anything going to the west will be negative. So just spend a few seconds just doing this, just to be consistent here. All right, so what we're going to do is we're going to be looking at these diagrams and looking for the overall force acting on each of these objects. So the way we do this is just by looking at it visually, first of all. So visually, what you can do is just say, okay, in the first diagram here, I've got 50 and negative 50 in my horizontal. They cancel. I don't have to worry about them. Here, my forces are going to be 40 and 25, which gives me an overall force of 15 downwards. So the sum of the forces for the first one is going to be 15 newtons down, or negative 15 newtons if you wish. And that means that this object is going to be accelerating southward as a result. Okay, let's look at the situation here. So here we've got vertically, we've got 50 going upwards, 50 going, or sorry, north, 50 going to the south. So these forces cancel. And what happens here is that my overall force is going to be in the horizontal. So the overall force is going to be 10 newtons to the east. And same thing over here, the vertical forces cancel, so I don't have to worry about them. And my overall sum of the forces is going to be in the eastern direction. It's going to be 20 newtons to the east because we've got 40 and 20, right? So fairly straightforward. Well, what did we really do? What we really did behind the scenes was the following, okay? When you're looking at the totals, you did this. You looked at the totals in the horizontal and then in the x. So we look at this, the totals in the x. So here they would be 50 newtons and negative 50 newtons, which would be 0. And then you'd be looking at the y, and the forces in the y would be positive 25 and negative 40 newtons, giving you the 15 newtons downwards. And you did this for each of these. So basically, you did the following. And again, you did this in your head, but we're going to do it mathematically over here. So we've already seen the first one. The second one is very, very, very similar. So you look at the total forces in the x. So horizontally, we've got 20 positive and 10 negative, giving you 10 newtons overall in the x towards the east. Vertically, you're going to have positive 20, positive 30, and negative 50, 0. So your overall force is to the east. I think you get the idea. But that's kind of what we're doing behind the scenes. It's really important when you're adding numbers in free body diagrams of force vectors is to take into account the x and y components. You'll see why in a couple of questions. So here's the next question that we have here. So we've got a tow truck and it's moving a car with an applied force eastward. So we've got an applied force here. And then the force of friction is going against that, it's going westward. We also have force of gravity downwards. So we have to look at the forces that we have here. So I'm going to have vertical forces and horizontal. So vertically, up will be positive. And we're going to have east positive in the horizontal and west. So with that in mind, let's draw a sketch including these values now of what's going on. So let's look at the vertical first. So in the vertical, I'm going to have my force of gravity acting on the car. So Fg is going to be negative 8,000 newtons. But the car isn't falling, so you have to be careful. Sometimes you have questions, they don't give you all of the values. You have to interpret and figure out some of the missing values. So here's a classic example. So you have to assume now that, wait, I must have some kind of normal force, and that must be the same size as gravity. So what else do we have here? Then we have the applied force, which is going to be going forwards. Here we go, or sorry, eastward. So applied force is going to be eastward. So positive 4,000 newtons. And then we have a force of friction going backwards of negative 1,500 newtons. So what we want to do now is we want to look at the overall forces in both the x and the y. So let's look at the y first. So in the y, I'm going to have two forces. They're going to be the normal and gravity. And the two values are going to be 8,000 newtons. There should be another zero here, positive, and 8,000 newtons negative from force of gravity, which is zero. So I don't have to worry about the horizontal forces. You can still do it in your head, but you have to show me your work. Prove that the y forces add up to zero. Now what's happening in the x? I'm going to have my force of friction and my force applied, and they're going to be 1,500 newtons negative and 4,000 newtons, again, should be zero here, positive. You add this up, you're going to have an overall force of 2,500 newtons. Which way? It's horizontal, positive, so it must be eastward. So therefore, the sum of the forces acting on the vehicle are going to be in the x only, and it's going to be 2,500 newtons towards the east. So in your final answer, you need to include the values that you're using. You have to have a total and also have to have a direction. And in many cases, you have to worry about significant digits as well now. So they come back after a bit of a holiday, I suppose. Okay, so here we've got another question. Now this question, we've got a bunch of people fighting over some calculator. So they're all pulling, so these are all applied forces. So what I'm going to do is I'm going to number them. This is my first force. This is my second. This is my third force over here. And that's what we have here. We've got east, north, south. So we're going to be going north positive and east positive for my forces. Okay, so let's see what we have here. Free body diagram. So in here we've got 140 newtons to the east. So put that in here. This is F1, 140 newtons to the east. I also have another force here. So this one is going to the south. I'm going to use a different color here for the, oops, should be a different color for the vertical components. There we go. This person's pulling down to the south. The last person is pulling upwards towards the north with a force of 100 newtons. So what we're going to do here, just like we did before, we're going to look at the totals in the x and the y. So let's look at the x. So in the x, horizontal, I only have the first force. So my total in the x is going to be 140 newtons to the east. Now, what happens in the y is I'm going to have my F2 and F3 forces. So they're going to equal 40 newtons, should be negative over here, sorry, negative 40 newtons and 100 newtons, which gives me a total of 60 newtons. And it's positive, so it's going to be going northwards. Wait a second, what's going on here? I've got a total in the x and I've got a total in the y. I have to combine them somehow. Oh, wait a second, I've seen this before. So we're going to have to use the Pythagorean theorem, and we're going to also have to use tan to figure out the direction. So what we're going to do is, now that we've got a total, we have to draw a new triangle. So I'm going to start by drawing a triangle towards the east. Here we go. This is my F1. So again, just like when we did our displacement vectors, 140 newtons eastward. And I'm going to have my, sorry, this isn't my F1. This is going to be my sum in the X. Sorry about that. Now my value in the Y is going to be 60 newtons. And what I want to determine is, what is this value over here? So what's the angle, and what is the overall sum of this particular, of these two vectors together? So what you do is you do the Pythagorean theorem. So it's going to be the square root of sum of the forces in the y squared plus the sum of the forces in the x all squared. And then for the angle, you're going to use tan of the angle is equal to opposite over adjacent, and you'll get your values. Now remember, you can also have sketched the opposite triangle, and that's fine. Your angle will be measured from a different cardinal point, compass point. It makes no difference. Okay, so let's look at a complete example here. So what we did here is, as I mentioned, we did the Pythagorean theorem. We had our value of 152.3 newtons. My angle's 23.1. And bring it all together, depending on how you sketch it. If I sketch it like so, it'll be 150 newtons east, 23 degrees to the north. If I drew the other triangle, it would be 150 newtons north, 67 degrees towards the east. Either one would be fine. Doesn't matter which way you do that. The only thing we have to do here, we have to round to significant digits. So we really should be rounding to one significant digit. We're limited, I think. No, we're not. Yeah, by this 100 over here. So your final answer should really be this. So the sum of the forces should be, well, rounding to the even number would be 200 newtons east, 20 degrees north. Or if you did it this way, 200 newtons north, 70 degrees to the east. Sorry about that. Okay, so normally I don't like to have one significant digit. It just happened to work out like that this time. All right, we're going to do one more here. So what we have now is a question, but look what it has. It has an angle in it. Oh, what does that mean? We're going to have to break it apart like we did with our displacement vectors earlier, and then recombine the vectors to form the x and the y, and then get the overall Pythagorean theorem. So I want you to try this one out yourself. You can probably do it by now. Okay, so here's my little sketch. So I'm going to be going north is positive, east is positive. And what you're going to do is you're going to sketch a little triangle. Let me actually go back and show you how we do the sketch. All right, so here we go. And then you can continue, we'll check the answer. So north is positive and east is going to be positive. So what we have here, we're going to have the following. We're going to have a force that's going to the east. This is this one here. So let's call this F2. It's going 15 newtons towards the east. But now I've got another force. It's going northwest in this angle over here. So something like that. So this is going to be F1, 22 newtons, and it's going to be north 38 degrees west. Well, what does that mean? I'm going to have to break this apart into the y component and into the x component. How do I do that? I use trigonometry. So in this case, the y is going to be determined from sine, or the x, sorry, it's going to be determined from sine, and the y is going to be determined by cosine. And then once I have those, I can find my overall total in the x and y, and then be in business. The only thing I suggest is, instead of leaving the triangle like this, I suggest that you leave the F1y here, but then the F1x, bring it down on your free body diagram. I like to draw a new free body diagram sketch. It makes life a lot easier. So you can much easier see what's happening in the x and the y. So I'm going to be finding the totals in the x and y. Then I'll do the Pythagorean theorem, tan inverse, and get my overall total. The answer is over here, 17 newtons, east 85 degrees north, or north 5 degrees to the east. Either answer would be acceptable. So let's see what you have done. So pause and then check your answer. Here we go. So again, I have this. It's a little bit wordy. You don't have to have all of this here, but this is what you might want to jot down as your exemplar for this particular question. So again, first you do the x and y components from sketching your triangle. You redraw the vectors. I really suggest that. Find the total sum in the x and the y. Do the Pythagorean theorem after you've drawn the sketch, tan inverse, and get your final answers. And here we're going to be rounding to, looks like 2 significant digits. And that's it. So you have a few more examples to practice. We're going to be using this a lot this unit, so it's really important you do spend some time practicing. And that's it. Take care, guys.